And before we continue on with 3.5, I think, or 6, I wanted to point out an error that I put a note on in the last video. It happens at 3653, and it's regarding question D on 6. When you do synthetic division, you indeed have to remember to take the 2 at the beginning and divide it into each of your items that you come up with to get to the actual uh, coefficients. However, the book made a mistake. The remainder is not minus 2. You never take your remainder and divide it by the number in front, the number in front of your x. You only do that with these, and that's because the remainder is a thing left over that could not be divided by your divisor, like that, and is actually expressed like this. It's the minus 4 left over that could not be divided any further by 2x minus 3. Keep this in mind. It comes important later on. And the book got the remainder wrong, which might lead you to believe that you're dividing by 2 to get to this remainder. But I confirm with long division that the remainder is indeed minus 4. And feel free to go ahead and do it with long division to find out for yourself. The book will sometimes have errors, not often, but sometimes. Don't convince yourself it's a mistake. Find another way to verify the answer. So moving on to some 8 and 9. 8's pretty easy. 9 is pretty tricky, and 9 will help your math skills, but some of you might have trouble grasping it. Goes back to the basics of math, but let's go on 8. 8 is very easy. Determine the remainder of r to make each multiplication statement true. So if you look at this, you would simply expand this, and you're going to be left with some x squared, some x, and always a number. Now get used to the notion that your biggest term will always be your 2 biggest terms multiplying, and your number will always be your numbers multiplying. There's no other way to create the biggest term and the numbers. So there's only going to ever be one multiplication unless there's that's not true necessarily. Sometimes there's missing terms, but the biggest term times the biggest term will always create your biggest number here, and your number versus your number will always create your number at the end. There's no other way to create a number except a number times a number, which means that if I expand this all, and they're saying I add a certain remainder, I'm going to get this. Now, at first, you might just focus on the numbers, which would be correct, except sometimes you can have other types of remainders, and they want you to understand it. But the secret to solving this is realize where you're trying to get. This is where you're trying to get. There we go. And realize how you're going to get there. Now, the only thing that's missing is an r. And it's like any algebra problem. So if I expand this out, I'm going to get 6x squared. So I know I don't need to add anything there because I have my 6x squared. I'm going to get plus 10x and minus 9x. Plus 10x minus 9x is plus x. And I can see I have a plus x here, so I'm not going to have to add anything there. So the only thing left is the number. So the number, when I multiply the number out, is minus 3 times 5. It's minus 15, plus a mysterious remainder. And it's going to equal to the thing I know I already have over here, and the thing I know I already have over here. But it does not equal the number I have. So like any algebra, you simply solve this. If you want to see it logically of what it looks like, you can just rearrange it. It's r minus 15 is equal to 5. I add 15 to both sides. If I add 15 to both sides, this will cancel out. You're allowed to do anything to both sides of an equation, and you're left with r. What's 5 plus 15? R is equal to 20. So if you check your book, sure enough, the missing r up here is 20. And it's the only way when expanding this equation and adding 20 that you will get 5, which makes sense because when I take minus 15 and add 20, I will get 5. There's no need to add x squareds or x because exactly what I want on the right side is already on the left side. That's all you do for these. You multiply out and see what's missing. And you might be tempted just to focus on the numbers, but they get tricky and they indeed put in some things that aren't just the numbers. So here's where we're trying to get to. And here's where we start. So we're going to figure out what we have on the left and how it compares to what we want on the right. Just like that. Keep that in mind. right, so start by expanding it. And actually they put the, I already have the plus r, I don't need it twice. So if I expand this, I get x squared, which is great. That's already there. I don't have to worry about it. Plus 5x plus 3x. That's plus 8x. But look on the right. I have a 9x. Now you can solve this whole thing algebraically, and I will this time. And then finally, I have 3 times 5 is 15. But look on the right. I have a minus 7. So that means my x is going to be adjusted, and my number is going to be adjusted. And so then we have plus r here. Now, if you do it algebraically, you'll discover it works fine algebraically if you do the whole thing algebraically. So let's do it, the whole thing algebraically. How do I get rid of my x squared on the left side? I'm essentially just trying to get r all alone, which means I have to get rid of all these things. Since it's r plus x squared, I simply subtract x squared on both sides. If I do that, I can see the x squareds disappear, and that's why algebra works for solving these, even if you use them all together. And actually, the way that your teacher would want you to do it is to expand the entire left side and solve for r algebraically. So that means the x squareds cancel out, because when I subtract from both sides, they disappear. Now, how do I get rid of the 8x? Well, it's being added to r. So I subtract it. Now, some of you might say, how can you tell it's being added to r when it's just in the beginning? I can see that r is being added to that. But you always have to remember, when it's not showed, there's an invisible plus there. If you look at each thing going on, the 8 is multiplying the x, but it's being added to other terms. So if I want to get rid of 8x, consider it like a married couple, I subtract 8x from both sides. Clearly it disappears on the left. What is 9x minus 8x? It's 1x. So I'm left with 15 plus r is equal to x plus 7. So I can just get rid of that 9. X minus 7. What's my last step to get r alone? I subtract 15 from both sides. So what's minus 7 minus 15? It's minus 22. So I can see that I'm left with r is equal to x minus 22. If you look up your remainder, you will discover that's true. And by the way, you can always put a plus x and plus minus 22. So if I expand this whole thing, for instance, I get x squared plus 8x plus 15. And if I add an x, it becomes a 9x. And if I subtract 22, it becomes minus 17. Oh, so it's minus 17. Oh yeah, this is plus 15 rather. If I subtract 22, it becomes minus 7. So I can see that by putting this here with that and expanding this and then adding an x and subtracting 22, I do indeed get my final result. That's how you do all these. These ones are the simple ones. Number 9, not so much. You're going to have to warp your head a little bit, unless you're really good at algebra. Then you won't have to worry. So, again, on the right is what we want. And on the left is what we start with. And we're missing an r. So, if I expand this, I get x cubed, which is good, because I have x cubed over here. And then I have minus x plus 3x squared. So don't get confused there. The reason that doesn't work is there's an x squared here and an x there. So it's minus 1x plus 3x squared. So I can just do plus 3x squared minus x, because you want to put your terms in the right order. What's the order? Based on their power. So x cubed first, x squared next, x next. And it's minus x because x times minus 1. And look, here's the only number we're going to produce. Plus 1 times minus, plus 3 times minus 1. And then don't forget we have an r. We have this at the end. Okay, so you can just solve it algebraically. This plus r is going to equal that. So if I subtract x cubed from this side and x cubed from this side, the x cubes disappear. So I can just get rid of them, really. Whenever you see identical terms on opposite sides of an equation, they will cancel each other out. When I subtract 3x squared from this side, and 3x squared from this side, they disappear. So you can see the x squareds are gone. I'm left with minus 1x minus 3 plus r. And if you want, you can rearrange that. That just becomes r minus x minus 3. By the way, the x squared on this side disappear. Now, if I add an x to this side and add an x to get rid of it, minus x, got to add an x, and I added x to this side, the x's disappear. Notice that they're like terms. They're the same term on either side of the equation, so they will disappear. And I'm left with that. And finally, when I add a 3 here and add a 3 here, we see my remainder has nothing. Which means that this, when you expand it, x plus 3, x squared minus 1, will equal exactly this. So there is no remainder. You see how algebra helps us solve that. We're going to use algebra a few times, so keep that in mind. Here's the last one. It's the same thing, except that notice we have a few extra terms in there. And there we go. I'm going to just do it like that. And since it's the last one, I'm just going to move 9 up to have more room. So this is what we start with, and this is what we're trying to end with. So the secret is to expand it a bit. What's x squared plus 2x, so x cubed? It's 2x to the 5. What's x squared times minus 1? It's going to be minus x squared. But notice that we're going to have a plus 1 times the 2x cubed. So we have a bigger term right here, which is why I left that space there, because the 2x cubed. In reality, you should put this term on the left side so that you can get the biggest terms first. But it's okay. So you get plus 2x cubed, which was created when I multiplied the 1 times the 2x cubed, plus x squared, or sorry, minus x squared, which was created when I multiplied the x squared times minus 1. And finally, plus 1 times minus 1 is minus 1. Notice that we do indeed have some like terms on each side. You can always know that those are just going to eliminate themselves. We have some opposite terms here, though, and it's a mistake to think they cancel out. They don't. This plus x squared is opposite of x squared, and you'll see what happens. But you can still use algebra to figure it out. So on the left, if I subtract x squared on the left and x squared on the right, 2x to the 5 rather, they will disappear. So you can see that like terms pretty much cancel each other out. So plus 2x5 here canceled out with the plus 2x5 here. Same with the 2x3. This is a positive 2x3. 2x, yeah, that should be a 3. And you might be tempted to see, oh, but there's a subtraction here. No, but this is a positive here. To get rid of it, you have to subtract 2x3. And when you do it on both sides, they disappear. I'm left with minus x squared is equal to plus x squared, or just x squared plus 1. Now, it's a mistake to think those are the same. Because how do you get rid of minus x squared over here? Or if you want, how do you get rid of minus 1 over here? You have to add 1. You have to add 1 to both sides. And look at that. That becomes a 2, not a 1. So now I'm left with minus x squared. Oh yeah, there's a plus r here. That's what we're trying to figure out. It's r. I forgot to add the r in here. Is equal to x squared plus 2. Now when I add x squared to both sides again, this thing doesn't disappear. It becomes 2x squared. So what we're left with is r is equal to 2x squared plus 2. And if you look it up in the book, pretty sure you'll see that, let's see where it is, 2x squared plus 2 right there. Now let's go on to 9. I'm just going to copy this over. 9, if you're going to do it algebraically, is very complicated to get your head around. But I want to go through something here. And that's the terms. When I take my dividend and divide it by my divisor, That's what long division is. And up top, I'll be left with a quotient. And at the bottom, I'll be left with a remainder that could not be divided by my divisor. That's really what I'm left with, remainder divided by divisor. For instance, when I have 7 divided by 3, it can go into 7 2 times. 2 times. I'm left with a 1. If I stop there, I'm left with 2 and 1/3. Let's see if that's true. Let's look. I should get, if I put 7 divided by 3 in a calculator, 2 and 1/3 is the same as 2.333 repeating. Let's see if that's true. 7 divided by 3 is 2.33333. So you can see that this one remainder isn't just 2 plus 1, which is how we'd be tempted to think about it in polynomial terms, but it's 2 plus whatever's left over that could not be divided by the divisor. I want you to keep that in mind. Okay? It's whatever the remainder that could not be divided by the divisor when we kept it in whole numbers. Okay, so that again means when I take my dividend and I divide it by my divisor, I get a quotient plus the remainder that could not be divided by the divider. Let's write this out in words. Okay, and I'm going to get rid of the circle. So that means when I take my dividend and I divide it by my divisor, it is equal to my quotient plus, so a big old plus here, my remainder that could not be divided by the divisor, or my remainder over divisor. So let's look at this question. I'm just going to put all the answers in one spot. Let's look at this question. They give us the dividend, so they give us that. They give us the quotient, they give us that. And they give us the remainder, so they give us the remainder, and we're just left with this mysterious divisor in both situations. We don't know what this divisor is. So I'm going to replace the word dividend with a letter D. And it's being divided by our divisor. We're trying to figure out our divisor. And it's equal to the letter Q plus, in brackets, the remainder R divided by divisor. Now what we're going to do is see, and actually let's just write this like a fraction instead, is see if we can come up with an equation, and we should put this all in a big bracket, in which we can solve for the one word in there, because that's the one word we don't know. We do not know what the divisor is, and we're trying to solve it. Now, you can think of this as x. We're trying to solve for x. And the one thing you want to have when you're done with x is x over 1 at the top. Essentially, x is equal to whatever. Is it at the top here? No. You cannot just leave it there, because when you're done, you'd be left with 1 over x, which is not how we're going to solve x. We're going to solve x by having it x, essentially, over 1 is equal to that. Well, how do I get it from the denominator to the numerator? There's several ways to think of this. If later on when you want to do shortcuts, whenever you're presented with a fraction that's true, like that, you can just flip them, reciprocate them, and it will also be true. That is also true. So it works. The problem here is you don't really have a fraction here that works. You'd have to put this over the fraction of divisor. So you can't just flip them. And you could if you put q over divisor, but we're talking about making it more complicated than it needs to be. But when you have two simple fractions, you can just flip them. But I can't do that here. So how do I get the word divisor on the left side to the top? Well, anytime you want to get a denominator to the numerator, you simply multiply it by its reciprocal. So technically that's 1 over divisor. So I multiply it by divisor over 1 on both sides. Divisor over 1 on both sides. What happens here is it'll cancel. But you have to remember to do it on both sides. That's the golden rule of math and chemistry. Whatever I do it on one side, I have to do it on the right side. Well, it's going to cancel out on this left side. I'm going to be left with my mysterious dividend, which is what my D stands for. But this entire bracket is going to be multiplied by divisor over 1. In order to solve for divisor, I have to resolve this. So let's multiply it through as we would any distributive function. When I multiply it by q, I get divisor times q. Remember, we're trying to solve for divisor. So I get divisor times q. And then when I multiply it by this next thing, it becomes plus. And remember that d is equals on the left. Or that's dividend, not divisor. Remember, we used d for divisor. When I multiply the right side, these cancel out, and I'm just left with the word remainder. So I'm left with plus r. Again, that's because divisor times r divided by divisor is pretty much divisor divided by divisor, which is 1. So I'm just left with the r. So this is what I'm left with. Now, I'm trying to get the word divisor all alone. But when we're getting something all alone, we have to do reverse BEDMAS. I can't divide by q here because this plus r doesn't have a q in it. I mean, you could. It's going to get a little funkier than you have to do. So really, you got to get this term, which is multiplying each other, alone. To do that, you subtract r on both sides. This might be blowing your mind, but it's a lot better for you to understand how to figure out. And I'll give you a concrete example with that 7 divided by 3. So now we're left with d minus r is equal to divisor times q. And we're trying to get the divisor all alone. Well, again, this is a numerator. It's essentially over 1. So if I multiply by the reciprocal 1 over q, or in other words, if I divide both sides by q, that's what multiplying the reciprocal does, I will get rid of the q on the right side, and it will become a denominator on the left side. Suddenly, I have an equation to find any divisor. It's probably the toughest equation to come up with, too, in this case. So that would mean divisor is equal to the dividend minus the remainder times the quotient. Let's check that out with 7 divided by 3 is equal to 2 with the remainder 1 over 3. So this is the remainder. This is the dividend. This was the divisor, which we're trying to figure out. We don't know. And this was the quotient. So according to this, it's going to be 7, which is the dividend, minus the remainder, divided by the quotient, which was 2. Will that produce a 3? Let's see, because we know we're working, the answer is 3, right? All right, well, what's 7 minus 1/3? To do that, you convert your 7 to 1/3 if you want, which is 21 over 3, minus 1 over 3. I'm just working with the top here. What's 21 minus 1? It's 20 over 3. So the top becomes 20 over 3, and it's all divided by 2, which is essentially 2 over 1. Whenever you're dividing fractions, you don't divide the fractions. You instead keep the numerator fraction, and you multiply it by the reciprocal of the bottom, 1 over 2. Oh, it's not working out, so I did something weird. This was the dividend. That's the remainder. That's the quotient. 21/20 over 3 is 20 over 6. Oh, it didn't work. That's weird. It should have worked out. So I got dividend, which is 7, minus the remainder, which was 1 over... I think it's just supposed to be 1 in this case. Because, I don't know. It's supposed to be 1. Okay, so it's just minus 1. Yeah, because I've already accounted for the 1 over 3. Sorry. I've already... When I originally did it as remainder divided by divisor, I shouldn't have used 1 over 3 because that was the divisor, and I've already just solved the remainder. Sorry, that's where I'm screwing it up. It's not minus 1/3. It's simply minus the remainder because I already got rid of remainder divided by divisor. Sorry. So in this case, the remainder is 1. So I'm left with, yeah, because you don't want it, you don't know the quotient. You can't use, you don't know the divisor. You can't use the 3 here. You're only working with the remainder. So sorry, that was my mistake. So you got dividend minus the remainder, which is 1, divided by the quotient, which was 2. Well, 7 minus 1 is 6, divided by 2 is indeed the divisor we were looking for. Just to prove that it works, because I screwed that one up. And again, I've already isolated the remainder, so I don't have to leave it in the form. This is the form when we knew the divisor. Well, we don't know the divisor. So I should have just used the 1. So let's see if it'll work for something like 8 divided by 3, which is 2, with a remainder of 2. Now, pretend we don't know the 3. Here is the dividend, 8. Here's the remainder, 2, divided by the quotient, here, 2. What is 8 divided by 2? It's 6. What's 6 divided by 2? 3. It gave us the divisor. That will work for any, you can test it out with any number to see that this equation does indeed work. My bad for making it confusing there. You might say, well, why, Pete? You've gone to a lot of trouble to figure this out. Okay. If I look at the question and just try to figure it out logically, you can come close. You can come close to figuring it out, because I'll phrase it graphically what they're looking for. So let's just remember this is our equation. Let's forget the numbers and all that. It's dividend minus remainder over quotient. What they're looking for is they're looking for what number, so they're not giving us a term, rather. Divisor can divide into this dividend, produce this quotient with this remainder. And remember, in this case, it's going to be a remainder. Now we're just going to use the minus 123 in this equation, but technically you'd have to figure out divided by the divisor if we just were doing it graphically the way I'm doing it now. The other problem with this is, notice that it goes on the numerator here, goes x cubed, x squared, and we're missing an x, so you have to add another term in there, plus 0x, which makes it even harder. But the question essentially is asking, what divides into this and starts producing this? And it gets very complicated until you remember, oh, I used to figure out a number here multiplying the first term that would produce 5x cubed. So clearly the first term is x, because if 5x squared times x is going to produce 5x cubed, which logically you can figure out. But then when suddenly you're looking at this next term, you're like, oh, Jesus. Okay, well, if it's x, suddenly I got to figure out something that has a result of minus 4x, which is over 14x, which is actually over here with the x that's missing. I don't have an x squared, I have a 0x squared. So somehow I have to come up with 0x squared, and I'm using 5x squared, and it gets so hard to try to figure out what that thing is being added to x to produce that. It's almost impossible. So visually, trying to figure out what am I multiplying by this by to get this with this remainder. Yeah, you can write it out like this. You can say, well, logically, it's my divisor times this plus the remainder that's going to equal this. But suddenly you're doing exactly what we did when we figured out this equation. It's a lot easier now that we figured out the equation instead of individually going through this chaos each time. Visually, this is probably the hardest one to figure out. So now instead, since we have this nice equation, we're going to take divisor. We don't know it, but we know our dividend. It's that. We know we have to subtract our remainder, so don't get confused by the signs though. So our remainder is like this, And I should have just put whatever minus remainder in brackets up here. So it's minus whatever our remainder is. It has no, whatever it is independent of this minus. All over, and what was our quotient? This. Well, let's figure out our above part first. Because this we're just going to use long division to figure out divisor. What is 3 minus 123? Well, it's plus 126, right? It's plus 126. Well, I'm just going to get rid of the whole thing. There we go. Plus 126. So suddenly, I have something that's doable. I'm going to take this, which is missing a couple things. I'm going to divide it into this, and I'm going to get my divisor. I'm just going to put this equation back. I wish I'd left it a bit more clean, but it's still good. And I'm going to get my divisor. Just remember that we're missing are we missing anything here? We got x squared, x, and 42. Good. We got x cubed, x squared. We're missing an x. So we're going to put in, we're going to shuffle all of these a bit out, like that. And we're going to put in a missing plus 0x, which is essentially what's there. It's nothing plus 0x. Okay. Now we're going to do long division. And we're going to come up with our divisor. It's going to produce the missing information. So long division is the same way. How do I turn 5x squared into 5x cubed? That's my only concern. I multiply by x. So I'm going to do it. 5x cubed minus 14x squared minus 14x squared plus 42x plus 42x. And you can see sort of why we had to put the 0x in there. When I subtract this, these cancel out. Minus 14x squared becomes plus 14x squared plus x squared. So I get 15x squared, 15x squared. And plus 0x plus 42, or minus 42x. You might say, well, it says plus 42x, but remember, you're always subtracting. The next line is that. So I'm left with 15x squared minus 42x. So now we bring down our number. There we go. Now I ask myself, how do I turn 5x squared into 15x squared? It looks like it's going to be plus 3. When I multiply the 3 times the 5x squared, I get 15x squared. When I multiply the 3 times minus 14x, I get minus 42x. And when I multiply the 3 times the 42, I get plus 126. When I subtract this, this cancels out. This becomes a minus minus, which is plus, so these cancel out. And this becomes 126 minus 126 cancels out. So you can see there is the beautiful divisor right there. You might say, this seems longer. Yeah, I think you could have guessed in many ways what the divisor is, but I think it's harder. So you could say, okay, what do I have to multiply this by to get, you could say, well, all I have to do is figure out the numbers. 3 times 3. No, that's where this remainder screwed it all up, right? It made it hard. You could say, okay, well, all I have to do is figure out the x squared, and the x squared over here is 5. Well, no, that means 3 times that x squared didn't produce that 5x squared. And whenever you want to make sure of your answer, you take your divisor that you found, x plus 3, and you see if it could have gone into the dividend that they showed us. And remember that you're missing an x in this dividend, so you got to have a plus 0x. And the whole point is you're going to get this quotient with this remainder. Okay? So this is verifying can take even longer. So how did I get this? I get 5x squared. So far, so good. There's 5x squared. When I multiply it out, I get 5x cubed plus 15x squared. Good enough. When I subtract these, I get minus 14x squared. Now I bring down my 0x. My next number is minus 14 is what I do to create a minus 14x. And look at that. There it is over there. Minus 14x to get minus 14x squared. When I multiply times x, I get minus 14x squared. When I multiply times the 3, I get minus 42x. When I subtract this, I get plus 42x. And when I bring down the 3, I discover that my last number is plus 42. There it is there. When I multiply times the x, I get 42x. When I multiply by the 3, I get 126. And when I take 3 and subtract 126, I get a remainder of minus 123. So you can see that you can go back and check your results. But you can see that this formula, and figuring out these formulas, is a really good scientific thing to do, because you will save yourself a lot of time and frustration trying to bend your head around it. Remember that algebra statements, as long as you follow the rules of math, will end up being true. It's the benefit of learning algebra. Okay, well, let's try it with this one. So according to me, my divisor is going to be equal to my dividend, which is this, minus my remainder. Unfortunately, my remainder is positive, so I can just write it like that. All of it divided by my quotient. My quotient is this. Get rid of the word remainder. Now, all I have to do is figure out what's minus 2 minus 968. Well, it's minus 99,700. You can see you're dealing with some horrific numbers. So we're dealing with minus 99,700. There, we're ready to divide it. Now, the first thing to go is see if you have all the terms. X to the 4, oops, x squared, it jumps. We need an x to the 3. There's no x to the 3. How about here? X cubed, x squared, x. This is good. So the only thing we suddenly have to add up top, we have to say, well, we're missing a plus 0 x cubed. Otherwise, your division doesn't balance out now nicely. So we're essentially taking this. And doing long division. There's a way I can just kind of squish this to the right. Yeah. We're doing long division with this. You can see how long it can get. And we're asking ourselves, fortunately, you only have to deal with the first term. How do I make 10x cubed into 10x squared? Well, it's x. So it goes in x times. So if I multiply the x, I'm going to get 10x to the 4, which is what I want. Let's just make this a little bit smaller now. When I multiply by minus 100x squared, I get minus 100x to the cubed. When I multiply by 99x squared, I get plus 99999x squared. And when I multiply by the minus 970, I get minus 9070x. Now I have to subtract that. These cancel out. Minus 100x cubed becomes positive 100x cubed, because it's 0 plus 100x cubed. Minus x squared minus 999x squared is minus 1000x squared. 1000x squared. I think I got that right. Plus 20x minus 9970x is actually plus 9970x, which is plus 990x. And then I can lower my number, minus 99,700. Now I go to the next number. How do I turn, this is the whole secret here. How do I turn 10x cubed into 100x cubed? Well, I simply multiply by 10 plus 10. And if you got the right number, these should all be equal or opposite to these, so that when you subtract them, they'll cancel out. So let's see if that's true. So I'm saying it's x plus 10. 10 times the first term does indeed produce our 100x squared, x cubed rather. 10 times minus 1000x squared produces negative minus 1000x squared, the same as the term above. 10 times plus 990x does indeed create 990x. And 10 times minus 9970 creates 99,700. Busy, very busy. Yeah, okay, thanks. Thank you. I'll get it, thank you. And then when you subtract all this, no, I'm good, thank you. They all cancel out. So you get 0. And this is how you know x plus 10 is a factor. Now, yeah, you really, once you do the first two terms, so long as you're confident with your division, you can get it right away, right here, plus 10. And you can stop, but I strongly suggest for the first few times you make sure you get it right. Now, this is a fairly challenging question, and I'm surprised it's in here like this. But anyway, you can use the same formula over again. So according to me, the dividend minus the remainder, which in this case is just 31, so we can just do minus 31. If it was negative, it would become plus 31. All going to be divided by the quotient. Okay, what's minus 1 minus 31? Minus 32. So you just replace this with minus 32. And it's the same process. Now again, once you get the first two numbers, you're pretty much going to have it. Are we missing any terms? X of 4, x of 3, x squared. Oh, we're missing our x. These ones are fine. So we have to produce up above a plus 0x. It's very important to do that, otherwise your columns won't line up. Plus 0x. So we're essentially going to do long division, this divided into that. After we do the first one, we should be able to see the number. So how do I turn x cubed into x to the 4? It's x. If I multiply out that x to the divisor on the left, I get x to the 4 minus 3x cubed plus 2x squared minus 8x. Now, I have to subtract that from the stuff above. Minus 3x squared plus the x cubed above becomes 4x to the 3. Minus 10x squared minus 2x becomes minus 12x squared. You can already see the number appearing. And plus 0x minus 8x becomes plus 8x. And you ask yourselves, how do I turn x cubed into 4x cubed? Well, it's plus 4. And you already have a good idea that it's probably going to be plus 4 just from that. Just don't forget to bring your number down now. If I multiply 4 times my divisor on the left, I get 4x cubed, exactly what I want, minus 12x squared, exactly what I want, plus 8x, exactly what I want. See how it's matching everything up above it? Minus 32. And when I subtract all those, they cancel out, and I get 0. So you can see this formula works very well, so long as these are the exact quotients and rules. So x plus 4 is the divisor. And then finally, the last one is the same process. Use the little formula I got, and I might have to quit off this. So according to me, it's the dividend minus 19. Let's just solve that right now. What's minus 7 minus 19? Minus 26. All divided by the quotient, which is that. So you're just going to do long division again, and you're going to probably figure out the number right away. And the long division is just the same as always. So x obviously is my first one. Oh, am I missing any terms? No, fortunately this one I'm not missing any terms. I should space it out a bit though. I'm going to just try to space it out a little bit. There we go. So when I multiply the x times my divisor on the left, I get x cubed plus 3x squared plus 13x. And then when I subtract each of these things, x squared minus 3x squared is minus 2x squared. You can pretty much see what the number is going to be right there. 7x minus 13x is minus 6x. And then you got to bring the number down, minus 26. So what number do I have to multiply 2x squared to make it into 2x, negative 2x squared? Negative 2. And just to make sure, I'm going to multiply the negative 2 times all my stuff on the left, all my divisor. And minus x squared, I should get minus 6x, I do. And I should get minus 26, I do. And that's what I'm doing here is I'm multiplying the minus 2 times all the terms over here to get this. And when I subtract them, they indeed cancel out. Which means my factor, my divisor is x minus 2. So you can see wrapping your head around that is the hardest part. Your teacher might have a simpler solution. There's probably a very easy trick to coming up with a number. But to just put it there and not have this written down, or sorry, not have this written down, and to try to figure out what has to be up here to produce this can be very confusing. I mean, you can start with x and multiply it all out and get this first line. But then you're going to have to really... Yeah, I suppose you can subtract it and come up with that. And then you're going to come up with a number. I mean, it's possible to do it just intuitively. But I don't know if that's really going to help you wrap your head around it. So they're going to see, determine whether each binomial is a factor. So they want you to do long division. Now there's a little trick here. What's the root of this? It's minus 5, right? If I put minus 5 in this equation, if it's a factor, it's going to come out as 0. They're not going to teach you that to the next chapter. What they want you to do is do synthetic or long division and see if the remainder is 0. If the remainder is 0, it is indeed a factor. But the shortcut is putting this minus 5 into this equation, and if it comes out as 0, it is indeed a factor. Now I think I'm going to have to stop. Actually, I'm just going to run and grab a coffee. I only need 10 seconds. You can fast forward. Sorry about that. Okay, I'm back. All right. So they want essentially to see if it's a factor. I suggest you do a couple long divisions. Now I've done tons of long division here. So I'm just going to do synthetic division. And the secret is, if it is a factor, it will come out as 0 remainder. So synthetic division still involves figuring out the root. What is the root? Minus 5. What is it dividing into? This is it here. Let's bring down the numbers in front. Am I missing any x's? No. 1 plus, pardon me, minus 1 and minus 30. Now the secret is you kind of draw a reverse long division and you bring down the numbers one by one. So 1. What's minus 5 times 1? Minus 5. And in synthetic division, you add them. So plus minus 5 becomes minus 5. 6 minus 5 is 1. Minus 5 times 1 becomes minus 5 again. When I add them, minus 1 plus minus 5 becomes minus 6. When I multiply it, it becomes plus 30. Minus 5 times minus 6. And when I add them, they cancel out, which means 0 remainder. which means x plus 5 is not only a factor, but I also can tell you what the trinomial is. And you can even really quickly say, does this have a factor? And indeed, what number multiplies to minus 6 but adds up to 1? It's x plus 3 and x minus 2 and x plus 5 is the other one. So here's the free factors that will multiply out to get this trinomial. So indeed, the answer to the question x plus 5 is, we didn't need to do this last part, but x plus 5 is indeed a factor because the remainder was 0. You can see synthetic division is a lot faster. Let's try the next one. Am I missing an x value? Yes, I am. I'll just drag it over. I'm missing an x over here, plus 0x. So right here I have plus 0x. It's important to include all your values. And then what's the root of x minus 2? It's 2. 2. Let's bring down the numbers in front of each of these terms. It's 1, minus 5, 0. That's why we do it. 4. Let's make a reverse long division box. It just makes things easier. Let's bring down the 1. Is our first step. 2 times the 1 makes 2. When I add them, I get minus 3. 2 times the minus 3 makes minus 6. When I add them, I get minus 6. 2 times the minus 6 makes minus 12. It's quite clear the remainder will not be 0. When I add them, I get minus 8, which means x plus 2. Did I do the wrong one? It's supposed to be x minus 2. Let's see if that changes things. Bring down the 1 because I have to take the root, which is minus 2. Minus 2 times 1 is minus 2. When I add them, I get minus 7. Minus 2 times minus 7 is plus 14. When I add them, I get 14. And minus 2 times 14 is minus 28. So still not a root. When I add them, I get minus 24. So the remainder is minus 24, which means x plus 2 is not a factor. Pretty much what you're doing over and over again. Okay, what about this one? Oh, maybe I just did that one. No, that's why I got confused. Okay, what about this one? Okay, there's a missing term up there. See if you can spot it. It is indeed the x to the 3. So I have to have a plus 0, x to the 3 here. The root I'm looking at is plus 2 this time. That's why I got confused. Plus 2. The numbers in front of that, each term is 1, 0, minus 5, and plus 6. If I do the little reverse long division box, just keeps things nice and neat. Your teacher will want to see it. And I start by bringing the 1 down. 2 times the 1 is 2. When I add them, I get 2. 2 times the 2 is 4. When I add them, I get plus minus 1. 2 times the minus 1 is minus 2. When I add them, I get 4. So there's the remainder. So that means x minus 2 is not a factor of this at all. And you could have seen it pretty quickly. Oh, actually, you know what? X minus... No, because it's x to the 4. Had that been x squared and that just been x, you could have seen, yeah, that x minus 2. But because it's x to the 4, it's not a factor. But only in synthetic division could we find out quickly. Let's look at the next one. I'm going to just get rid of them as I do them. Am I missing a term in this one? Finally, I am not. Makes my life a little bit easier. What is the root of what I'm looking for? This is going to make it difficult because I'm going to have to divide. If I was going to do the equations, I'd have to divide everything by 2 at the end. Since they only want to know if it's a factor, I don't have to worry about that. What makes this whole thing equal to 0 to come up with the root? It's 1/2. When x is 1/2 here, this whole thing becomes 0. So that means I'm looking for positive 1/2 is positive 1/2 going to be synthetically division and come out with a remainder of 0. I start with each of my numbers. 2, minus 1, minus 4, plus 2, plus 1. Make your little synthetic division box just to make things a little bit easier. Start by bringing down the 2. Half times a 2 is 1. When I add these, I get 0. Half times this 0 is 0. When I add them, I get minus 4. Half times the minus 4 is minus 2. When I add them, I get 0. And half times the 0 is 0. When I add these, I get 1. So the answer is no. For D, 2x minus 1 is not a factor of this, because in synthetic division I got a remainder of 1. Let's just make sure that I think I have the answers here. And I'm dealing with, it says yes. Oh, I guess I did the division wrong here, so I have to go back. But this one says no. This one says no. And, oh, how come it's 3x plus 5? Did I get something wrong? It's not 3x plus 5. Oh, it is 3. Oh, no, I did D. So D says nope, not a factor. But it says x minus 1. That's weird, because that's not what I was looking at. It was 2x minus 1. So a little error there. And it looks like I did a mistake on this one. It says it is a factor. So maybe I should go back and make sure. I think I forgot the x cubed and the x. That's what happened. So going back to that one, I forgot the x cubed and the x on that one. So they're saying this one here. And sure enough, it's because I didn't account for all the missing variables. I only spotted the x, and I didn't spot the x cubed. So there's a couple of them. There's a plus 0 x cubed here, and there's a plus 0x here. So if I bring down the numbers, it's 1, 0, minus 5, 0, and 4. And I'm trying to see if minus 2 is a root. So that means that I can draw my box here. Bring down the 1. I get minus 2. Add them, I get minus 2. Multiply, I get minus 4. Add them, I get minus 9. Multiply them, I get plus 18. That doesn't work. So x cubed, 0, minus 5, plus 0x, plus 4. And the root they're looking for is minus 2. Doesn't seem to work. Let's try that again. Minus 2, 1. Minus 2 times 1 is minus 2. When I add them, I get minus 2. Oh, I see. Minus 2 times minus 2 is plus 4. When I add them, I get minus 1. Minus 2 times minus 2 is plus 2. When I add them, I get 2. Minus 2 times plus 2 is minus 4. When I add them, I get 0. So small arithmetic error. X plus 2 is indeed a factor, and it's because I forgot x cubed and x, and I'm doing arithmetic errors. So we've done that one, that one, that one, that one. So let's get rid of them. Synthetic division is fast, but sometimes when you're like me and you get complacent, you go too fast. Okay, look at some of the terms we're missing here. We're missing quite a few. We're missing x to the 4. So it's 0. And we're missing x to the 3. So it's 0. So I'll just put a 0 and plus a 0 in there. Now, what root is that? It's minus 5 over 3. I'll let you figure out how I did that quickly. So, since it's minus 5 over 3, I put it over here. And I just start by writing down the numbers. 3, 5, 0, 0, 9, 17, and minus 1. Then I do the synthetic division box. I start by bringing down the 3. 3 times minus 5 divided by 3 is minus 5. 5 plus minus 5 is 0. Minus 5 over 3 times 0 is 0. 0 plus 0 is 0. That times 0 is 0. 0 plus 0 is 0. That times this is 0. 0 plus 9 is 9. 9 times minus 5 over 3, the 3 goes into 9 3 times. 3 times minus 5 is minus 15. When I add them, I get 2. And I can see that 2 times minus 5 over 3 becomes minus 10 over 3 instead of minus 1. It does not come up as 0. Let's make sure, because I did that damn fast, that is not a factor. Yeah, and there's the remainder. Minus 13 over 3. And we indeed got some bizarre factor. Okay, they even came up with the remainder in their answer. Okay, the last one. I'm going to guess the last one is a factor. Notice there's some terms missing. That last number looks to be minus 10, by the way. I'll make sure so we don't waste everybody's time. It is indeed minus 10. We're missing some factors. We're missing the x squared, so I'm just going to put in a 0 here, plus 0. And the numbers are 5, minus 1, 0, 10, and minus 10. And what root is this? It's plus 1/5. Plus 1/5. So we're trying to multiply everything by 1/5. And we're going to bring the numbers down. We start with 5. 5 times 1/5 is 1. So I put 1 here. Minus 1, that's what it was here. Plus 1 is 0. 1/5 times 0 is 0. 0 plus 0 is 0. 1/5 times 0 is 0. 10 plus 0 is 10. 1/5 times 10 is 2. And when I add it, I get minus 8. Huh. I'm pretty sure the book said that it was a factor. Let's see what the book says and see how I screwed up. No, it says not a factor, not a factor. Not. They're all not a factor except for the first two. So it's not a factor because the remainder is minus 8, which is indeed what we got, I think. Let's see. We got minus 10 plus 2 minus 8. Yeah. Well, good not to screw it up. So 11. The volume of a rectangular box is given by this. So a box has 3 equal sides. The box is x plus, oh, well, it's not apparently. Rectangular box. The box is x plus 3, x plus 2, and they don't know the height. That's an interesting question. Well, the simple solution is you can multiply these two out and then divide it into this to figure out what the factor is. So that's what we're going to do. In case you want to know what I'm doing, here, I'll explain it. Always think in simpler terms. Okay. If I look at a rectangular box, I'm looking at something like that, something like that. All the corners are joined. Like that. I'm looking like something like that. Then you go about and you erase the invisible lines like this. Can't see that line. Can't see that line. And you can't see that line. And you'd be left with something like that. Right? Now, if I'm going to label this, I can label it x, y. So x is the length, y is the height, and z is the width here, right here. And we know that x times y times z will give us the volume, right? Right. Well, they've given us the volume right there. They said that's the volume. That's the volume. And they've told us our x, our length is not x, but x plus 3. And our width is not z, it's x plus 2. And they want to know h. Which means if I write this in mathese, x plus 2 times x plus 3 plus our missing value h is going to equal what? It's going to equal your volume. Our length, our width, our height multiplied is going to be equal to that. Well, I know I can isolate that by dividing this on both sides, but I want you to expand it first. X squared plus 3x plus 2x plus 5 is instead x squared plus 5x, right? Plus 5x plus 6. Is that correct? That is correct. And I could put it all in brackets like that almost. There we go. Good. All right, so how would I get rid of that? If I know that this times h is equal to that, so all this mess in a bracket times h is equal to that, well, I multiply each side by the reciprocal, or if you wish, I divide each side by that. Which means that, since this cancels out on the left, h is equal to the volume divided by the length times the width. In other words, if I long division that, I will get my height. If I long division it, I will get my height. Now, you could do synthetic division if it wasn't so complicated. It was a simple factor. And it might be, you could indeed take your original factors and long division it in twice. And then you should be left with, you could synthetic division your two factors twice, and you should be left with your result. And maybe we'll try both ways, because your teacher probably would be happy if you came up with both ways. But in this case, we're going to long division it. I'm not missing any terms here. I'm not missing any terms here. So what do I have to multiply with here to get x cubed out of x squared? It's x. If I multiply it out, I'm going to get x cubed plus 5x squared plus 6x, right? If I subtract everything here, these cancel out. 6x squared minus 5x squared, I get x squared. 11x minus 6x, I get plus 5x. Plus 5x. Now I bring my number down, plus 6. Now, what do I have to multiply x squared by to get x squared? And notice that this whole term is this whole term here, so it's obviously just plus 1. Plus 1 times that will get x squared. Times that will get plus 5x. Plus that times that will get plus 6. And when I subtract these down, I get 0, which means that x plus 1 is my missing height. Sure enough, if you take x plus 1 and you multiply by x plus 2, and you multiply that by x plus 3, you should get that. How would I do it synthetic division? You might go, oh God, well just go on to the next question if you don't want this. How would I do it synthetic division? Well, they give you the height and they give you the width. So you could do synthetic division twice into the volume. And it might be faster. What are the numbers in front of here? 1, 6, 11, and 6. What are the roots? Let's start with the simple one. The root here, minus 2. So let's start with minus 2. What's synthetic division? 6, 11, and 6. So you start with the 1. Minus 2 times 1 is minus 2. When I add them, 4. Minus 2 times minus 4 is minus 8. When I add 11 plus minus 8, I get plus 3. Minus 2 plus 3 is minus 6. I get 0 here. So I get 1, 4, 3. So that means I'm left with x squared plus 4x plus 3. And I can even see right away, I can even factor that to come up with x plus 3 and x plus 1. But let's say I want to do synthetic division again. So I know that indeed I've just done this one. So there's just this one left, and my synthetic division now will be from minus 3. What are my numbers in front of that? 1, 4, and 3. I bring down the 1. 1 times minus 3, minus 3. 4 plus minus 3 is 1. Minus 3 times 1 is 3. And I see I'm left with 1, 1. So what does that mean? Well, this first one is x, 1 less than that. And the second one is a number, plus 1. So you can see that I came up with it by using synthetic division quite quickly, just by dividing first the height or the width into that, and then the length into that to give me the height of x plus 1. That's what 1, 1 at the end means. Whenever you're trying to figure out the values, realize what you started with, lower the exponents of x by 1. X to the 1 becomes x to the 0, so that's a number. X squared lowered becomes x, so that's 1x plus 1. And the remainder is 0. This has nothing to do with the last factor. Two ways to do it. One was actually faster. This is divisible by 2x. There is no remainder, so find the value of p. Well, we can use synthetic division for that because this, we just have to remember to divide at the end. Let's try long division. When x is plus k is divided by x squared plus 1, the remainder is 5. Ugh. Ugh. Okay, well that one's actually not too hard. Let's try 12. I might have to give up on some of these. Let's try 12a. I think synthetic might be easier. So, am I missing a term? No, I'm not. Spread them out. What is the root of this? And just remember, we're going to have to divide every term by 2 at the end. What is the root of that? Minus a half. Minus a half. Yeah. Okay, let's lower each number. What are the numbers? Let's just use the numbers that are there. When I lower the 8 and multiply by negative a half, I get negative 4. So keep in mind that's going to be halved. When I add these, 10 plus minus 4, I get 6. When I multiply by half, I get negative 3. Now here's the trick. What number, since we are looking for a value of 0 here, this must become plus 5 to make a 0 here. When I look at these, I'm going to multiply some number by negative a half to equal 5. Well, it's got to be a negative number for one thing, right? It's got to be negative 10, right? Since I'm adding this p, since I have to add this to minus 3 to equal minus 10, this p must be negative 7, okay? And the negative's already there. So that p must be 7. Let's make sure and see if that's true. So according to me, it's going to be minus 7x minus 5. And I'll show you how I figured that out again in a second if it wasn't clear. Okay. Let's start with figuring out the numbers in front of that. Remember, this is the root we're working with. What are the numbers? 8 plus 10. And remember, I figured out it was minus 7, but just remember the minus 7 is p, and minus 5. I knew the first few numbers. I knew I'm working with an 8, and 8 times minus a half is minus 4. 10 plus minus 4 is 6. Negative 6 times negative a half is negative 3. I knew, and this is over here by the way, without knowing what that is, because I end up with a minus 5 over here, which will be this times whatever that number is, has to nullify that minus 5, because I have to come up with a plus 5 to nullify it. That means whatever I'm multiplying here times a negative half has to come out with plus 5. That means the only number I could be multiplying it by is a negative 10, because negative 10 times negative a half is plus 5. The only way I can get negative 10 by adding minus 3 is if that was a minus 7. So I kind of work backwards by knowing I need a 5 here in order to have a 0, because they told me there is no remainder, right? And that'll be the secret here too. In this case, a 5 will have to end up here. But anyway, because I know there's no remainder, I know my minus 5 has to be nullified by 5, and I know I'm multiplying by a half. So that means my result here has to be minus 10, which means my p has to add to minus 3 to make minus 10, which means my p must be minus 7. Since this minus is already in there, the p is 7. So if we go to 12a in the book, we will discover 7p, because I already put the minus in. Okay, let's look at the next one. The next one's a similar trick. Okay, first of all, there's some values missing, quite a few values, okay? But they're telling us k is a number. K is a number. First thing is, get those missing numbers in there, okay? And also know that this is our factor. Now, what's the problem with this? we cannot do long division. You cannot do long division here. Well, you could in a way, because the only way this is equal to 1 is when x is minus 1 and x is 1. But we're not going to do it like that. You cannot do synthetic division when x squared plus 1. So that means I'm stuck with doing x squared plus 1 long division. Long division or synthetic division, you need to find those missing terms. So we're going to have a plus 0 x cubed, x to the 5 rather. So I'll put that down so it doesn't look as goofy. And maybe I'll put this up too for the same reason. This is a minus. It's too bad they make their minuses so small. I think it was a minus, wasn't it? Oh no, it's a plus. Okay. Good thing I checked, because that would change everything. Okay, we're also missing an x cubed. So we have to have, again, a plus 0 x cubed. There. Now, the secret to this is that they tell us the remainder is 5. So that means, since I'm subtracting everything, at the very end, whatever I'm subtracting here from k has to come out with as 5. So that's how I'm going to figure out what k is, because I'm going to know the number here. I know I'm going to be subtracting it, and I'm going to result in a 5. So I just have to figure out what number that is minus this number is going to be equal to 5. So let's just do long division and just go slowly. All right, so I'm working with x squared plus 1, so we have to put in our missing 0x as well. Here, plus 0x. So you can see they made it fairly complicated. Okay, I'm just going to get rid of the question now that I have it. And oh yeah, I'm just going to remember that I have to come up with a remainder of 5. To come up with a remainder of 5. And I'm just going to get rid of it to have more room. Okay, I'm going to get rid of all the other numbers. And this is a plus 1 over here. Kind of botched it all up, but you get the idea. Plus 1. Okay, just going to clean it up so that I don't have as much mess. There we go. Still messy, but whatever. Make sure I get my pluses in there. I don't want to screw that up. There we go. I'm even going to do a long division bar so that we can see it. Raise it a bit. Okay, and then I'm going to put this a little bit there. Just make it nice and neat. Make it a little higher and even lower my screen a bit. There we go. All right. X squared to x6. I have to put in an x to the 4. When I put an x to the 4 and multiplied everything over here, I get x to the 6 plus 0x to the 5, which is good, plus 1x to the 4. And I start with subtraction. These cancel out, these cancel out, and these cancel out. So I'm left with 0 x to the 5 plus 0 x to the 4, and it's important to include those. And then I bring down my 0 x to the 3. All right, pretty obvious to make x to the 2 into 0 x to the 5. It's 0. So if I multiply it, I get 0 x to the 5, 0 x to the 4, and 0 x to the 3 is what it is up here, and 0 x to the 3. You might think that's useless, but it's really just keeping everything in order. And I get 0, so I'm left with 0 x to the 4 plus 0 x to the 3. And now I bring down my last number, minus 2x squared. Might not have to do this messiness on this one, but so I'm just going to get rid of that already and just work with what I have. How do I get 0x to the 4? I obviously multiply it by, let's just fix this a bit, 0 again. So I have, this time I multiply by 0x squared. And I get 0, 0x cubed. And here's the last one, 0. So this will finally matter here. When I add them together, I get 0x cubed, and this is the important part, plus when I add these, subtract these rather, I get minus 2x squared. And this is why it's important to keep it over. So this is my new line. And you just get rid of the old lines. Okay, what do I have to multiply x squared by to get 0x cubed? I have to multiply it by 0. X. This is the important part, because 0x will give me 0x cubed. And did I do it right? And 0 number. Yeah. Then when I add those together, I get minus 2x squared. There we go. Plus k. Here we go. Plus a number. Actually, did I do that right? I hope I did it right. I have to ask myself, what do I multiply x squared by to get minus 2x squared? It's minus 2. Okay. Minus 2 times x squared gives me minus 2x squared. Minus 2 times this 1 gives me minus 2. Remember, my remainder has to be 5. When I subtract this, this nullifies, and this becomes negative 2, which becomes plus 4. What number does k have to be to add 4 to get 5? It says k. I say k has to be 1. I think the book said 2, so I probably did something wrong here. I don't think I did, though. Oh, I forgot the x. No, it doesn't matter. I still accounted for it in the middle. I just didn't write it. I didn't think I made a mistake here. It's saying it had to be 3, so I did make a mistake somewhere. Minus 2. Oh, no. Yeah, that's just me making a mistake. That's stupid. What number do I have to add plus 2 to make 5? It's not 1, you idiot. It's 3. So really only the number mattered at the end. Minus 2 can make the only minus 2x squared. I could have just jumped right to that. Minus 2 times the 1, well, times 0x, but that doesn't matter. And I forgot to put a 0x here. And then minus 2 times the 1 makes a minus 2. I know the remainder is 5. I know I'm subtracting minus 2, which makes it plus 2. It simply matters saying what number plus 2 is equal to 5. K plus 2 is equal to 5. Therefore, k is equal to 3. Long, convoluted way to do it, but I think this just wanted to use one synthetic division and one long division. Here they do the same thing, but we're missing a number that's earlier on. They do tell us that 1 is a factor, and there's actually a really easier way to come up with it than this synthetic division. The next chapter, if we just put in 1, for this factor we get 1 plus mystery times 1, minus 1 minus 3, so it's minus 2, so that would mean p times 1 has to be equal to minus 2, so I'm going to say p is equal to minus 2. But let's just see if we can do it. Synthetic division. Synthetic division for this, the root would be plus 1. We have all the terms in there, and we simply have, we're just going to work with p, 1, an unknown p, minus 1, minus 2, and the only thing we know is that the remainder at the end here has to be 0, right? If it has to be 0, this has to be plus 2. If this is plus 2, I had to multiply a number here by plus 1 to get plus 2. I know that number had to be 2. The only way minus 1 can become 2 is if it was added to 3. The only way this 3 existed is if I multiplied it by 1 times this number to get 3. That means this number had to be 3. The only way this number could get to 3 is if I added p to some mysterious number to get to 3. Well, we can't do that there, so let's start at the beginning now. I lower 1, and I know 1 times 1 has to be 1 there. That means when I added them, p plus 1 had to be 3, which means p is equal to 2. Let me do that again for you, and let me do it the long way. I know synthetic division leads me to this, right? I know my remainder has to be 0 because it says it is a factor. I know my root is plus 1, so we're going to do it old school. I'm going to bring down the 1. 1, and I'll just put my root further away so that it's less close. 1 times 1 is 1. P plus 1, we can even do it algebraically here, is p plus 1. 1 times p plus 1 up here will be equal to p plus 1, right? 1 minus 1 plus p plus 1 will be equal to p. 1 times p will be p here, and the remainder has to be 0, which means minus 2 plus p has to be equal to 0. Therefore, p must be equal to 2. So that's another way to algebraically do it. You can then go back and replace p with 2 and see if it works out. 2. 2 plus 1 is 3. 3 times 1 is 3. Minus 1 plus 3 is 2. 2 times 1 is 2. So indeed, p is 2. So interestingly, you can leave it in as an algebraic term, and it'll still solve it in the end because you know the end result has to be 0. All right, 14. Let f of x, where n is an integer between bigger or equal to 1. Is f of x always divisible by x by... Yeah, it is. This comes from your knowledge of difference of cubes and the Pascal's square. Okay. So if I have x to the 2 minus 1, the factors are x minus 1, x plus 2. If I have x to the 3, 2 minus 1, I know that from my difference of cubes, x minus 1 is a factor. It doesn't matter what this is. This is a factor. What's interesting is as I go beyond that, if I go x to the 4, that's a difference of squares again. And here's one of the differences. I don't care about the second difference. This one doesn't matter. This has a difference of square again. And I can see right away, there's one of the factors I'm looking for. What about x to the 6? X to the 6 minus 1 is a difference of squares x cubed plus 1 and x cubed minus 1. Well, x cubed minus 1 is a difference of cubes again. And one of the factors of difference of cubes is x minus 1. What about the one I skipped, x to the 5? Right? That's a little trickier. X to the 5, how do I prove that x minus 1 is x to the 5? And I think they want me to do it with synthetic division, right? So essentially, how am I proving that plus 1, the root of x minus 1, is a factor when I have 0x to the 4, 0x to the 3, and 0x squared? Well, I'm dealing with 1, 0, 0, 0, and minus 1, and I just have to have a remainder of 0, right? Start with 1. 1 times 1 is 1. Add it. 1 times 1 is 1. Add it. 1. 1 times 1 is 1. Add it. 1. 1 times 1 is minus 1. Add it. 0. So synthetic division, like that, shows it's true. If I continue with x to the 7, no matter what I do, I have this pattern of zeros in between. X to the 8's no different. I'm always going to end with minus 1. The addition's always going to be 1. I'm going to always have a remainder, which means no matter what n is as an exponent, I'm always going to get a remainder of 0. It's very easy to intuitively see it for the first ones. Once you hit x to the 5, if you do synthetic division, you see that you always have this situation at the end. I don't know if your teacher will be satisfied with that. Let's see what the book says. Number 14. The book says, yes, it's always divisible by this. Regardless of the value, it can always be written as f of an x. Oh, you see, yeah, they do exactly what I did. And they show that all the zeros in synthetic division in the middle are zeros, and you'll always end up with -1 plus 1 at the end. There we go. Okay, let's see number 15. If the divisor of a polynomial is x minus 4, then the quotient is this and the remainder is 7. Write the division statement. Rewrite the division statement by factoring the quotient. Graph f of x. So they want the polynomial at the end. Well, I don't know why they want you to graph it. Okay. Let's just play along. So just, this might be, again, they want the divisor, so we might have to go back to it. So again, we don't know what, we know the divisor, we don't know the dividend. So dividend divided by divisor is equal to quotient plus the remainder over the divisor. We know the divisor here is x minus 4. Okay? So that, and we know the quotient is this. And we know the remainder is 7. So that means it's equal to this plus the remainder over the divisor, right? Well, we know the divisor, they gave us the divisor, is this, x minus 4, which we would put in brackets right here. Which means the dividend is going to be, if I get rid of this on the right, on the left, I have to multiply by x minus 4 over 1. And if I multiply this by it, x minus 4 over 1, I'm left with divisor, or sorry, dividend is equal to x minus 4 times the quotient and then when I multiply divisor over 1 times this part of the quotient, it can come out as just plus 7. So that means there's the division statement. Rewrite the division statement by factoring the quotient. Rewrite the division statement. Okay, so if I expand it and then find factors for it, and then they want me to graph without a calculator by factoring the quotient. So here's the quotient. So the factors of that quotient are x plus 3 and x minus 1. No, minus 2. So I can rewrite this. Interesting that they want me to do this. In the middle as this. Plus 7. That means you would normally, let's pretend that plus 7 wasn't there. You would normally go through the points 4, 0, 2, 0, which is here, and minus 3, 0, which means it would be right here, minus 3, 0, 2, 0, right here, and 4, 0, right here. That's 2, by the way, and 4, 0. But the whole graph is elevated by 7. So all these y's become 7. So it really goes through the point minus 3, 7, 2, 7, and 4, 7. I also know from the expansion, if I were to multiply this x times this x squared, I get a positive x cubed. So it's coming down like this, going up, and then coming down. And it's going through those 4 points. It's coming down here, going up, coming down, and then continuing on like that. So I could graph it like that. Okay? I could also see if it's going to touch the x-axis at least once, possibly twice. So I could expand that last one instead. Just remember the remainder is plus 7, but that's not a bad graph. So let's instead expand it first. Expand it first. Oh yeah, and they want us to graph the dividend, yeah. So I'm going to expand it first. So here's the quotient. I'm going to use my box method. And just got to remember that at the end I'm going to be adding 7. And then I got to do x on this side. Minus 4 on this side. I'm going to do my little box. When I multiply here, I get x. I'll go right across. I get x to the power 3. I get x to the power of 2. And I get minus 6x. And on the next line, I get minus 4x to the power of 2. I get minus 4x. And I get plus 24. Okay. When I add up these two terms, minus 4x squared plus x squared is minus 3x squared, and when I add these, minus 10x squared. So I end up with, oh yes, plus 24, and don't forget at the end I have to add 7. So this one's going to be 31. So when I add up all those terms, I'm just seeing if I can graph it differently. I end up with 1x to the cube minus 3x squared minus 10x plus 31 since I know a factor of it, comes up with that quotient. So I don't really know anything. I do know that it's possible for me to use a couple values of x. Oh, I do know its y-intercept is right here, 0, 31. So that's another thing I can do, along with the minus 2, 7, or minus 3, 7, 2, 7, and 4, 7. So there's 4 points. If x is minus 1, I get minus 1 plus 4 plus 10 plus 31. So minus 1 is not a good choice. Let's try plus 1. If x is plus 1, I get plus 1 minus 3 minus 10 plus 31. So no, it's not going to be plus 1. Let's try plus 2. Plus 2 squared is 8 minus 24 minus 80. So plus 2 isn't going to do it either. Let's try minus 2. Minus 2 cubed is minus 8. Minus 2 cubed minus 8 times minus 3 is plus 24. And minus 8 times minus 10 is plus 80. So we can see minus 2 is not going to be a factor. I'm going to just try 4, but I think I'm going to get a remainder of 7 at 4. Well, 4 is tough. 4 times 4, 64. So plus 64 minus, what's 3 times 64? 180, 192 minus 640. Oh, it's not that at all. It's not 7 quotient at all. Remainder 7. It's probably 7 over x plus 4. Rewrite the division stage by factoring the quotient. Okay, so I had x minus 4, x minus 2, x plus 3, plus 7, like that. Let's just graph it. X minus 4, x minus 2, x plus 3, minus 7. Let's see if I can do f of 4. What do I get? Minus 7. Good. F of 2. Minus 7. F of minus 3. Minus 7. Okay, so I was right. I put it on the wrong side of the graph, that's all. So I'm going to do minus 3 comma that in brackets. So I'm going to do 4 comma f of 4. I'm going to label it. I'm going to do 2 comma f of 2, and I'm going to label it. I'm going to do 4 comma f, oh no, sorry, minus 3 comma f of minus 3, and I'm going to label it. So I indeed discovered, oh, what's interesting about the remainder is it didn't raise it by 7, it lowered it by 7. Oh, I put plus 7 by mistake. There we go. It did indeed raise it by 7. So there's all the factors. There is an x factor. I got something wrong because it's, oh yeah, I got the whole begin and end value wrong. I had it in the wrong area. So it does indeed pass through here. It would have been impossible for me to figure that out. And it does indeed go through this here. So I did indeed get the second graph correct, which I came up with for no good reason, as x cubed, x to the 4, sorry, that should be x to the 4. No, x to the 3 times x squared times x. I don't know why I've cubed there over and over again. Sorry. Oh, okay. Yeah, I totally screwed up the right. That should be squared, and that should just be x. Sorry. So minus x squared, or plus x cubed minus 3x cubed minus, let's try that. X cubed minus 3x squared minus 10x plus 31. Yeah, same graph. So I could indeed figure out the y-intercept. I could indeed figure out these 3 points. If there was no, if the remainder had been 0, notice what happens. They become, and I'll get rid of this. Instead of 7, it would be 14 or 24. Notice if the plus 7's not there, those 3 points are x-intercepts. Those 3 points are x-intercepts. When the plus 7 is there, those 3 points were the former x-intercepts with a 7 as the y value. That's important. That's important. So you can figure out points in the graph, and you can roughly draw it, as I've done here. You just wouldn't quite know where the peaks are, and you wouldn't know where the actual x-intercept is. But you get a lot of information of what that 7 means. It means the y value is 7. Interesting stuff. I think they're just trying to help you work through it. Use an example to show how synthetic division is essentially the same as regular polynomial division. I gave you a good link for that. The volume of a cylinder is that. The can is this. What is the radius? Oh, that's interesting. Can cylinders are actually really easy to solve. And I might quit after this just because I'm supposed to go somewhere. If you look at a cylinder, right? What is it? Oh, come on. There we go. A cylinder is simply a circle at the end. And you know that the formula for the area of a circle is pi times r squared, right? Pi r squared. That is the entire area of this cylinder, or this circle. If I pile circle after circle after circle on top of each other, right? Boom, 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 right on top of each other, like Pringles. You realize that it's simply the circle times however many circles I've piled up. Or, in other words, the height of those circles. The height of those circles. In other words, if I put a circle at both ends here, and join them with a straight line, even though they don't quite match, I'll fiddle a little, cheat. Okay? We discover that we have a pretty good cylinder. Okay? The height here, multiplied by the area of the circle, will give you the total volume. Well, they gave us the total volume, and instead of height, they've given us this. They want to know the radius. Well, we know the radius is this, so we know the pi r squared is going to be what's left over once I factor this, once I divide this into that. Whatever's left divided by that, so essentially divided by the pi, will be equal to the r squared. Let's see if that's true. Let's write this algebraically. Pi r squared times the height will be equal to the volume. You with me so far? Good. Which means pi r squared will be equal to that divided by that. Right? I can go one step further. Let's get rid of the pi on both sides, divide by pi on all sides. Because this is multiplying this, and actually before I get rid of the x2, let's leave the x2 over here and divide by pi first. If I divide this by pi, I'm not allowed to divide that unless they each have a term of pi. And you can think of it as each one is an individual fraction over pi, which means the pi's will cancel out. So I can essentially just get rid of those pi's. And I'm left with r squared. Let's put this back. If I get divide pi on this side and divide pi on this side, each pi is going to disappear. So the pi's don't even matter. If you don't understand how I did that, I can answer the question. So the next step is we have this times that is equal to that volume. To get r squared all alone, I have to divide both sides by x plus 2. It disappears on the left when I do so. So I discover that r squared is going to be equal to this divided by that. Well, I can use synthetic division because that's a nice x plus 2. I'm dealing with a minus 2. Do I have x cubed, x squared, x, and 50? I do indeed. What numbers am I working with? I'm working with a 4, a 28, a 65, and a 50, right? Great. Easier than we thought. So that means r squared, and that's the important part, radius squared, is going to be the result of this. Okay? We'll start by bringing the 4 down. What's 4 times minus 2? Minus 8. What's 28 plus minus 8? 20. What's minus 2 times 20? Minus 40. Minus 40, yeah. What's 65 plus minus 40? 25. What's minus 2 times 25 minus 50? What's 50 plus minus 50? 0. So we have this, 4, 20, and 25. Great. We can factor, we're left with 4x squared plus 20x plus 25. Like that. But we can factor 4 out. We're left with 4x squared plus 5x. Oh, we can't factor 4 out at the end. Close, no cigar. But we can either use our quadratic formula, or we can see 4 times 25 is 100. Is there a number multiplying out to 100 that adds up to 20? 10 and 10. Interesting. That will add up to 20. Great. Now I can use the slip and slide or factor by grouping. Factor by grouping is like this. 4x squared plus 10x plus 10x plus 25. The first one I can only factor out 2x, and I'm left with 2x plus 5. The second one I can only factor out plus 5. I'm left with 2x plus 5, which means the two factors, I should have noticed it's a difference of squares. 2x plus 5. Not a difference of squares, perfect squares. It's 2x plus 5 squared. Right? But this is also equal to my radius squared. What's my radius? Well, if I square root both sides, I'm left with r. Both those squares disappear. I'm left with r is equal to 2x plus 5. You might say, well, there's also a minus 2x plus 5, but because we're working with dimensions, it's not true. We're only working with positive. So that means r is equal to 2x plus 5. You might say, well, is that the best we can do? Yeah, unless they give you a value of x, you cannot come up with r. Let's see what the book says. Oh, there's the graph. Oh, it looks like I forgot number 16. Okay, 625, I think it is. 635 or so. And we're at 5.5, 3.5? Not 5.5, 3.5. Sorry about that. Went way past. Ooh, way past. 3.6, 3.5. I think we're at 3.5. What chapter? I can't even remember what chapter I'm on. I think I'm in 3.5, right? There it is. Radius is 2x plus 5. And up here, I don't know, did I do 16? Guess I forgot 16. But there we go. Radius is 2x5. Oh, here they did long division here. Okay, so here, 2x plus 5. We indeed got the right radius. Now let me just add those answers because it looks like I skipped the answers, not realizing that was there. Yeah, it's on the next page, that's why. Good. Too bad I wrote all over this. Let's see, does it get rid of it? Oh, good. There we go. And then I'll just save it. Good. So, 16, did we answer 16? Back to 144. 177, right? There we go. Did I just get the wrong answers? No, there we go. So, did we do 60? No, this is just an example. So this, we just proved that, yep. Now they want us to divide it by this, and they want us to divide it by that. So a negative and a positive. And I think they're proving Pascal's triangle with this. See how it's a minus 2, plus 2, minus 2, and there's that. Notice that the y4 goes down, and there's the x, and 2, and that. And they just want us to do it in long form. This is a difference of cubes, so again, it's the same question as x minus 1. And there's that one I might not be able to answer. I don't know if I'm going to bother to do the long division. Go ahead and do it. You're always working with the first term. So, for instance, you're working with x squared, and then that'll produce your other terms for you, and it'll go down naturally. This is all part of Pythagoras' theorem, though. That is to show you that you can come up with any value of when you're working with binomial squares, when you're working with this, any term x plus any term y to any value here, you can work out with Pascal's triangle. Since they're working with minus y squared and minus x squared, they're talking about x plus y and x minus y. And I think they're just trying to show you a version of it. In any case, I'm going to leave that long division to you because you don't need me to do that. This I'm not going to answer because we essentially did it with x minus 1, except in this case it's a difference of cubes where it's x minus 1 is x minus y is the factor. This last one I'm going to try. And just to look at the answer for the other ones, yeah, so here they've done the division, and you can see that it comes out to pretty much what the formula is for difference of cubes, essentially. Go do it, and you'll see. Yes, this is pretty much answering the x minus 1. And it looks like 20 is going to be difficult. So the question is for 20. Ooh. If f of x is equal to that, so it's some quotient. In other words, what's the quotient? There's the divisor, and there's the remainder. What is the first multiple that is greater than f of x? That's greater. First multiple of x that is greater than that? Then the whole thing? I guess wouldn't it be x plus 4? And then they just want you to expand it? Maybe? I'm not quite sure what they're asking there. I'm going to work on my principle. The first thing that's greater than it is when we add 1, but that's not true. I'm not sure what they're asking for. What is the first multiple of x plus 5? So what, like a number in front of it by multiple? Not quite sure what the question is. Hard to answer a question when you don't know what the question is. Let's look at what the answer they say. They say it's going to be x. Yeah, so they're essentially just adding 1. If you look at the answer, they're just saying you take the quotient that you had and you're adding 1 times the x plus 5. A weird way to do it. I'm not sure how you derive that. You'll have to ask your teacher. Sorry about the last few questions, but you really don't need me to do the long division on those last two. You don't need me to do this one. You can long division that. And we've already answered that.